everybody, welcome back to the channel. I want to thank everybody who's been watching, and I want to thank all the new subscribers. Today we got called out to this oven. I don't know what kind of oven it is. It'd be some kind of a batch oven or a curing oven, and they're saying that not getting hot enough. So I'm looking at the set point, the set value, and then the actual value. So it's set for 350, and it's only getting up to 323 degrees Fahrenheit according to this controller. It has the output light illuminated, so that means it's trying to output. So I'm gonna have to see what's going on. If it's that close, it kind of doesn't make me think it's a heater or the heater. This is obviously an electric heated oven because I don't see any gas burner set up. There it goes. It went up 1 degree. I don't know if it's just not coming up to temp or if it's not coming up to temp fast enough. Kind of a cold day, but not that cold because this oven is taking this reading from inside that chamber. Let's see what we can see. So I'm looking at the exhaust. This is the exhaust housing, which exhausts out and it vents out the gases through the up into the atmosphere on the roof. And as soon as I opened the exhaust port, the temperature started dropping. So I'm going to go ahead and close that off, and we're starting to regain our temperature. So looks like we're gaining temperature. So it's not the exhaust. So the first thing I want to do is test my functions. I'm going to turn my functions off. Let's turn the circulation fans, which looks like it also doubles as a power on and off power switch. So we got that on. Turn on the exhaust fan, kick on our heater. So let's get this thing opened up and we can see what we can see. Maybe there's a trip breaker, or let's see what's going on in here. Let's see. Is that a manual? No. Spanish English dictionary. Somebody's trying to learn English or Spanish. Alright, so we got the panel opened up. Let's see what we got here. This thing looks like crap. This looks like our heating contactor, and this, I say that because it has the this contactor on it right here. I think that is like this is the type of contactor they use for heaters. I don't remember specifically, but I know what they look like. I think it's kind of got like some kind of like a fluid in it or something. It's not, so it doesn't keep using the points when the heater cycles on and cycles off, versus this type of contactor, which actually contacts 2 points. Because if the heater goes on and off so fast, it pulses, it would burn up those contacts super fast. So you don't want that. You always want to use a solid state contactor or relay in this case when you're dealing with heaters because of the pulse effect. Let's see here. So these look like they might be the fan, and this is definitely the heater. So the heater is running off this rack of fusing right here. So let's go ahead and check voltage. It looks like this is one of the blower fans. So this is the circulation fan motor down here, and that's going to be the exhaust fan motor up there. So I went and grabbed my flashlight and my meter, and I want to go ahead and verify that circulation fan motor is on. So circulate, because if the heat's not getting circulated, then the heat's not going to make it across the thermocouple. So yeah, this thing is on, definitely blowing. And also, if the circulation fan motor wasn't blowing, this pressure sensor wouldn't allow probably the heaters to come on because there was no fan or circulation or airflow. So anyways, we're slightly up to temp. It's like we're at 336 now. So I'm kind of wondering if they just didn't give it enough time to heat up. It's kind of what I'm thinking, and they called me out to this building and they're not allowing things to heat up before they call me. Kind of premature, huh? Anyway, so it looks like it's on its way, but let's go ahead and take a voltage reading and make sure that everything is functional since we're here. So I got my meter, and I have my meter set for volts AC, and I'm going to go ahead and try to put it somewhere where you guys can see it. Go put it right there on the roof. I'm going to focus on the heater circuit. This is a very simple circuit. You got power coming in. This is your main lugs, and then it distributes out to another fuse block, which feeds your, looks like it feeds your blowers. So we're going to check this contactor, which it doesn't look like it's in the best shape. All that kind of soot build up around it. So let's go ahead and take a voltage reading on the supply. That is going to be 472, and we're running at 480 volts. And that is 476, and then A 473. So let's go ahead and check the bottom side of those fuses and make sure that we are going to read absolutely the same from A to B, A to C, and B to C. So we're reading 473, 473, and 476. So let's check the contactor. Top of the contactor is 473 from A to B. From B to C, it's 476. Now from A to C, 473. So this is the load side, so that's the line side of my contactor, which means your supply voltage. And here is the load side of my contactor, which means it goes to the business end of this oven. 473. What is going on here? Voltage drop, baby, right here in this contactor. You guys seen it here first with me. Okay, so we got on the line side 475 from A to B. From A to C, we got 474. From B to C, we got 478. So we have 480 all across. So let's see. We had 480 all across the line side of our contactor. So let's go ahead and verify. So from A to B, we have 480 volts. From A to C, 230. And from B to C, we have nothing. There we go. From B to C, we have 230. So I believe there's a voltage drop in this contactor, which is not heating up all of the heaters. So let me see. We're not engaged right now. So this thing kicks itself on and off. It pulses. That's why it's kicking on and off, because it has, I think it's like a pulse control where it doesn't want to keep the heater on continuously. So it pulses at intervals. And we're at 342 degrees where we're set to 50. But it looks like we're only operating one heater. So let's go ahead and check our coil voltage and make sure we're good there, which I'm sure we are. So we have 123 volts. Yeah. So I think there's a huge voltage drop in this contactor. We're gonna have to get this thing replaced. So right now it looks like it's only operating off one heater. That is crazy. Yeah, so when you're using pulse control on these kind of contactors, it blows out the points. And I can see by all that buildup on this thing, all that brown soot, that this contactor is probably smoked. So let's go ahead and see if we can get one ordered, and we'll head back to this job and get this thing swapped out. But for the moment, even though it's operating off of one heater, it looks like one heater has carried the load all the way. So we're at set point of 350 and an actual value of 350 operating on one heater. So that means with all three heaters, we would probably be able to go back and open up this vent or exhaust and maintain heat control, because once you open up the exhaust, it exhausts out all the heat, and there isn't enough heat input versus heat output to maintain a temperature. So I think that's what's going on here. Okay, so now that we got this thing powered down, I'm just gonna go ahead and give one final little check. Make sure we have our power off. Everything looks good to the touch. No power, no power, no power. All right, so we are powered down. So I'm gonna go ahead and start the process of getting this contactor out of there. Looks like these two wire nuts are what feed into my coil, and this wire nut, yeah, so if you look at and we pay attention to what's going on here, this is absolutely redundant. We have a contactor feeding a contactor. That doesn't make any sense, but hey, it's 2025, things don't make sense anymore. So let's go ahead and pull this load side wiring out, line side wiring out, get that all taken out. All right, so get the load side down, let's get the load side taken out. So it's just a straight shot, one down, one down, one down. We're not dealing with the motor here, so we don't have to worry about rotation. You get those pulled out, get those pulled out. Since we're gonna keep our magnetic base, we're gonna keep the base, we're only gonna swap the control portion of this. I don't need to open up, I don't need to take the base off, I only need to take the faceplate off. And let me show you guys how to do that. So what you're gonna wanna do is you wanna get a fine point screwdriver, and underneath this little block, this little latch right here, underneath this little opening right here, there's a little latch. You're gonna pop that latch upwards, and you're gonna do the same thing for the bottom side. There's a little latch that will pop out the high current side portion of your contactor. Okay boys, so we're back, and I didn't have a 30 amp contactor. I did have one, but it was a 24 volt coil, which isn't going to work because the setup is different on the internals. But I got to doing some math or some looking around, and I started asking, why did this heater setup need 30 amps? I bet you this whole oven doesn't even run off a 30 amp circuit. So I went to look at the main fuses for the entire oven, and it's only 20 amp fuses. So I went to look at the fusing for just the heater circuit, and we're at 15 amp fuses for the heater circuit alone. Which, why are they using a 30 amp contactor on a 15 amp circuit. I think somebody just put that in because it's maybe all they had at the time. I don't know. Like I said, I'd have to get a hold of the drawing and kind of see what this thing is asking for. I don't even believe this is the right setup. You can see the old imprint of what used to be there, and it wasn't an Allen Bradley contactor. So I don't know. I think this was a fuse box going straight to the primary contactor, which I think this is the only contactor. I don't know. Like I said, I'd have to look at the manual and kind of see what was here. But for the moment, if we're going to do a plug and play situation, I have a 20 amp contactor right here ready to go off of 15 amp fuses. That'll work just fine. So I'm going to go ahead and swap this old contactor out for this 20 amper, and I'm going to try to get a hold of the manual and see what I can see. So the first thing I'm going to do, I'm going to pull out this coil, because this thing is shot. Yeah, this thing has seen better days. You can see all that soot and that smoke. This is definitely not the right kind of contactor for this, but hey, I just showed up to the party. Yeah, this party's been going on a lot longer than I've been around. So let me get this. They don't even use the right style bolts, but whatever. It should be DIN rail mounted. I don't even think this is the right contactor, like I said. Maybe I'll put a DIN rail on here. Okay, so I just got the contactor base plate off, and you know what? I think I'm gonna mount a DIN rail just to make everybody's life easier, since we're already gonna go with the same setup. And you know, looking at this plate pattern, I don't think that was a contactor there. I think that was another set of fusing. So you have your main fuses. I'm not sure. Like I said, I'll have to get the manual, but that is not a contactor. That is not a contactor for just a basic set of heaters. I don't really believe that this thing used sets a contactor. I have to look at the manual and see. All right, boys, we're back, and I got a piece of DIN rail cut ready to land this bad boy up in there. And let's get this thing on a DIN rail mount so it's easier to take in and out. Okay, so I just got my first screw in. Let me land my second screw. We'll get this contactor mounted up and wired in. All right, so I got my DIN rail mounted, and I'm gonna get my contactor landed. There it is, 20 amp contactor, 15 amp fuses, ready to go. So let's go ahead and get this thing wired in, see what we can see. So on my way to wiring in my A2, you can tell this thing has been Frankenstein, because you got a copper wire and then you have an aluminum wire. So this thing has had more hands in it than you know what. Yeah, who knows how long this oven's been alive and getting kind of just added to and taken away from. This is not the original, definitely not the original components that came with this thing. Alright, so we'll get this thing all fastened down. So this one is going to be the same thing, 20 inch-pounds of torque. It says, yeah, it'll be about 15 inch-pounds of torque on this. Get that all taken care of. So let me get my load side wiring. Okay, so I got my load side all wired in. I'll come back and I'll just do a torque. I'll torque down all these bolts with my torque wrench. And for the moment, let me get my line side plugged in. We'll get this thing started up and see what happens. Okay, so I got my line side all wired in. Now I'm gonna torque this down to the 15 inch-pounds. Oh, there it is. 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 And there's my last one. Alright, so we'll go ahead and get this thing powered back on, and looks like everything is good. My coil's set, my line leads are set. Let's go ahead and power this thing back on and see what happens. Okay, so I'm gonna go ahead and throw this recirculation fan, which is also the power on. So we got our first fan blowing, I can feel it. We'll turn on our exhaust fan. Now let's go ahead and cycle on these heaters and let's see what happens. Alright, so my new contactor just sucked in. So let's go ahead and take an amp reading on these heaters and let's see what they're pulling. Alright, so I got my clamp meter and we are pulling 13.8 on the middle, 14 on number 1, and 13.8, essentially 14. So every heater is pulling 14 amps, but we're operating on 15 amp circuit, on 15 amp fuses. So that leads me to believe that I need to raise the size of those fusing with that fusing, and I put a 20 amp contactor in there, so it should be able to hold it no problem. And everything is looking good. So it looks like we're pulling current across the board very evenly. Now let's see what the temperature looks like, but I'm gonna get to talking to them about this whole setup, and let's see what they want to do. I can't just make changes to this place because they have a whole booger eater team that kind of decides what happens to their machinery, so it's not my call. I know a lot of people out there probably like, hey, well, just do this. It's just not my car. I gotta play by the rules here. So we have our heaters on. Our set point is 350, and we have our output indicated on our temperature controller, and it looks like we are rising fast. So this heaters are cooking in there. Now that it's using the other two heaters, I think they were only operating on one heater. Now they're operating on two because this contactor took a dump, gave up the ghost on two of these terminals. Yeah, look at those terminals. Those are horrible. Contactor is a contactor, no matter what it looks like, what color it is, what name brand, it does the same thing. If it says it has a rating, that one is rated for 20 amps, which your fuses are rated for 15. So it's even rated over the overcurrent protection device. So our heat is rising fast. So anyhow, boys, I'm gonna stay here and babysit this thing and make sure that everything is operational. We already did the current check. Let's go ahead and do a voltage check real quick. Here we go. 480, 480, 480. Let's check the load side of the contactor. 480, 480, and 480. Well, there it is, boys. This one was kind of an easy one, with the exception of not having the wrong part that they originally put in, which it doesn't need that, but I'm gonna have to definitely get with these booger eaters and get a drawing out of them somehow, some way, and see if I can see exactly what is required for the control side of this oven, and we'll see if we can't get everything plugged back in the way this thing is designed to be. I would like to get it back to factory spec, but like I said, it's outside of my wheelhouse, boys. I'm just here to change parts and figure out their problems for them. So I will see everybody later, and I thank everybody for tuning in. I really appreciate the view, and if you have not yet, go ahead and subscribe. And by the way, hit that like button, guys, just for the algorithm. I want to thank everybody for watching. I appreciate it. Bye.